Welcome back to the agricultural drought assessment. In the last video lecture, we have discussed about the classification of drought into meteorological drought, hydrological drought, and agricultural drought. We have further seen different types of agricultural drought also. In the present video lecture, I hope by the end of this video lecture, you will be able to explain the procedure of predicting and monitoring of drought. So our main concern is about how agricultural drought is being predicted and how it will be monitored all across the globe or in some parts of the globe or particularly in our country. So agricultural drought is predicted mainly with the help of these two factors. The first one being monitoring teleconnection phenomenon like ENSO, which is nothing but both a combination of both El Nino and southern oscillation. So this particular El Nino, as you might have heard about this word, it is nothing but there is a, if you carefully observe the globe, the map of the Earth, then you can see there is a Pacific Ocean which will be lying between your America, South America, and it will be linking the lower parts of the Asia, and it will be extended up to Australia, if you carefully observe. So there is an entire stretch of the Pacific Ocean there. Now, this Pacific Ocean, the water body, and the atmosphere over it, they will be a change in the pressure. Is what which we can you can easily understand. So the change in pressures, sometimes it will be too hot, sometimes it will be too cool. See, there will be three stages, particularly in the El Nino. One is El Nino, the other one I think is a neutral stage, and the third one will be a cooling stage. Basically, I think non-in, I think the name it is somewhere like that. So these three stages means during one particular region, there will be an enormous energy exchange between the ocean and the atmosphere surrounding it. So during the first stage, there will be particularly we do observe in Asia. Particularly, we do observe this one in Indonesia, and which are the lowest parts of Asia. We observe in Indonesia during one particular El Nino, the rainfall will be reduced. In the neutral, it remains the same. Whereas again in the non-Nino, then automatically what happens is the rainfall gets increased. So this cycle of El Nino, it repeats over a period of years. So sometimes there will be hot winds blowing there, and sometimes what happens is these pressures will create cool winds to flow through over this Pacific Ocean. So this is going to affect the monsoons, particularly in our country. So the drought in our country is somewhere or some are more related to this El Nino and also the southern oscillation. So the same has been mentioned here. So the pressure differences between the waves which are created over the Pacific Ocean, they are weakening the summer monsoon and related to drought occurrence in our country. So studying of this ENSO, this El Nino and southern oscillation, may give us a good understanding of agricultural drought, prediction of agricultural drought. The second one is the analysis of long-time climatic records. If you go, it's not just seeing the last 1 year or 2 years or 5 years or 10 years. We need to look into the past 50 or 40 years rainfall or monsoon. So then we come to know what is the definite cycle of drought occurrence. So studying this entire duration, a very long duration of rainfall or monsoon for the past 40 or 50 years, it gives us some information of the cycle of drought, for how many years it is coming regularly. And particularly by the Indian Meteorological Department, which basically looks into this agricultural drought. There are 6 predictors to forecast the Kerala monsoon. Every time, if you carefully see, in the month of May itself, they will announce that when the monsoons will enter Kerala, by what time they will enter Telangana, by what time they will enter AP. And like this, they will enter the dates, possible dates. They will inform us. So how the IMD, the Indian Meteorological Department, is capable of predicting these states? So this is the 6 predictors what they will be using to forecast the Kerala monsoon, or what we call it as the southwest monsoon, because our Kharif season or Vanakalam season basically depends upon this Kerala monsoon. So these are the 6 important factors, and the bottom 4 factors are also which are employed by the IMD to predict the Kerala monsoon, to forecast the Kerala monsoon. See, you can go through all these things. And next is monitoring and early warning of agricultural drought. This is the most important thing. See, why this is most important thing is agricultural sector in our country basically it has been stretched over nearly 30 to 40% of the land which is available in our country. Most of the people still in our country are farmers. So if there is no early warning regarding the agricultural drought with them, then the entire money which they are spending in sowing the seeds and etc., it will be wasted. So that's why you need to warn those people that an agricultural drought is going to come, and thereby you are supposed to make up the minds of the farmers. So that is always required in an agricultural country like this. So how this agricultural drought is being monitored and an early warning is issued. Now, in the next slides, we will come across these things. See, prediction of drought is neither accurate nor precise, but it is critical for planning for preparedness and also mitigation plans. As been discussed earlier in the last video lecture itself, we cannot accurately, precisely estimate the onset of agricultural drought, but we need to plan for that with some preparedness and mitigation plans. If we want to have them, we need to plan for that accordingly. So in our country, particularly in India, this monitoring of this agricultural drought and these warnings issued in our country are basically taken up by the responsibility will be taken up by the IMD, Indian Meteorological Department. And these people, they will inform the state governments and also the central government. And these state governments and central governments, they will inform through news bulletins or through some media channels or news channels with the help of their agricultural ministries. So how this IMD is able to predict these things? So IMD basically maintains, see the third point here, IMD maintains a network of 2,800 rain gauge stations all across our country. So these are distributed across 36 meteorological divisions across the country. So every moment it will be watching this, how much amount of rainfall is there across this 2,800 stations. And the DST, Department of Science and Technology in our country, in collaboration with the ICAR, has set up 89 centers for short and medium range monitoring and forecasting of weather. So these 89 centers, they will forecast and monitor the weather. Now, by conventional methods, nowadays the satellites have been come into picture to predict this vegetation and the rainfall, etc., etc. But in the olden days, we used to rely on the conventional methods. Even in most of the areas now also, we are relying on the conventional methods. So how these conventional methods, what are these conventional methods? How this Indian Meteorological Department or this governments, how can they get an estimate of what is the drought? How can they estimate of prediction of drought? How can they predict the drought? See, the first step, what they will be doing is nothing but there will be a revenue department in every state. What you call the Tahsildars, you might have heard about this one, the Tahsildars. They will be looking after the district or the one particular area. So these people, they will give the amount of rainfall which is received in their particular area to the revenue department of the state. These revenue departments in the state, they will collectively give the information to the central government, revenue department of the central government. And then they will estimate what is the amount of rainfall in these regions. So see, state, this is the first one. Revenue department of each state, it collects the rainfall data at each tehsil and district. The second thing, what is the amount of agriculture and what are the different types of crops and what is its condition, were there any pests attacked, and other agriculture related information will be collected by the agricultural offices and it will be accumulated at the state agricultural departments. See the second point there. State Agricultural Departments, they collect information on the crop condition, health and pest attacks, etc. And this one, Crop Weather Watch Group, CWWG, along with it works closely with the Central Agricultural Ministry to integrate the above data. So, deliberations of group and exchange of information with similar group at state levels, it triggers and activates a drought response systems. Apart from above, state governments, they will be having their own state weather watch groups and institutions to monitor the droughts. Even in our state, we do have it at Hyderabad. At AP, they do have it at Vizag. So they will be having separate things to forecast the weathers. So depending upon this, all tahsildars and agricultural departments and these weather watch groups. So what were the limitations which we experienced? What were the limitations? What are the problems which we experienced? The data was completely inaccurate. It was difficult for us to collect the information from all these guys and from all the farmers from every village, etc. etc. And the information processing was also time consuming. So that's why what happened is there was a lack of availability of near real time data. So to overcome this particular thing, the governments have started utilizing this spatial information technology for monitoring of the situations, climates. So how they have started utilizing the spatial information technology, we will see now. See, the remote sensing from wide range of satellite sensors. This has found to be useful to assess the agricultural drought. And unlike point observations of the ground data, which is being done, the satellite sensors provide direct spatial information on vegetation stress caused by drought conditions. See, from the satellite, they will take pictures and they will see whether there is a greenery or whether there is a lack of greenery in a particular region. They can zoom to whatever extent what they can with the help of the satellites. They can get more accurate images and they will assess the drought conditions. So, unlike the point observations of ground data, satellite sensors provide direct spatial information on vegetation stress caused by drought conditions. What is the color of vegetation? Depending upon the color of vegetation, whether it is green means okay, it is healthy. If there is a light color deviation means okay, it may be a pest attack or something else. So like that. So it is sensitive to changes in leaf chlorophyll, moisture content, and thermal conditions. This spatial information technology. So polar orbiting sun synchronous satellites, they provide information of crop conditions synoptically at regular temporal intervals that enable monitoring during crop growth season. So many satellites have been sent in by the agricultural department also, which they will monitor this crop growth and they will provide information at some regular intervals. So satellite sensors, they record the reflectance, emission and backscattering of electromagnetic energy from features of the earth, the vegetation, soil and water. So how they get the pictures, you all know. Based upon the scattering of the waves, emitting of the waves, radiating of the waves, they will take the pictures and they will send them to the earth. So drought can be detected 4 to 6 weeks earlier than before, more accurately. Because it will be just like every 1 minute or so, you can get the picture images. Nowadays, fast satellites are coming to picture, advanced satellites have been coming to picture. So you can see the vegetation very clearly, very closely from the satellites itself, rather than employing all these tahsildars and sending them all to the villages and getting the information. And nowadays, it has become more advanced. So you can easily predict the drought. So the conclusions. I hope by now you have understood what are the traditional methods of ones which were used to monitor and assess monitor the drought, and what is now satellites. What is the role of satellites in assessing the drought and monitoring the drought? So the conclusions are: drought is a progressive disaster which affects a large population, and hence it is to be suitably predicted and monitored. And in India, most of the prediction and this early warnings, they will be done by the IMD along with the state and union governments. And remote sensing from wide range of satellite sensors can be employed to assess agricultural drought very effectively. So with all this, I'll conclude this particular agricultural drought assessment. In the next video lecture, we will continue this agricultural drought assessment and we will see what are the different types of indicators which are employed by the governments to assess the drought. So far now we have concentrated on how to monitor the drought. Next we see how to assess the drought.